So it's been a little while since I updated you on the status of our AI Edge Compute Wildlife Monitor, and you can see that we've come a long way since the first, or one of the first versions. So you can see this thing is completely 3D printed out of ASA plastic, which is very UV and temperature resistant, and we've got some ventilation ports here as well. So fully self-contained. It has 4G Wi-Fi and or optional LoRa connectivity as well. And one of the main things that we've developed is actually this PCB at the back here, which provides that connectivity. Another thing that it provides us, that if you've been following along, you'll know I've had a lot of problem is to do with this thing up here. So having a compact and efficient way of charging high capacity batteries that would also interface with the Raspberry Pi, so we would know what the status of the battery is and also what the power level coming in is. So one of the biggest frustrations was we couldn't find anything that would interface with the Raspberry Pi that would do all that. And so that is one of the main features of this PCB here. So it can provide up to 10 amps charging of a range of batteries, up to 120 watt solar panels. This is just a 60 watt solar panel. And I've currently got in the back here a very large 220 watt hour lithium ion battery. But I've also got another version of this that is powered by a much larger external lithium iron phosphate battery that is also being charged by a 120 watt solar panel, and that would allow for full 24/7 day and night operation with the thing running the object detection models the entire time. So that PCB carrier board for the Raspberry Pi that we developed has an onboard microcontroller as well as a few sensors and some input and output switching, and as I said, the 4G and LoRa. There has been a lot of interest in potentially selling this PCB board. Unfortunately, it is quite complicated to program the firmware on there. If I tried to use commands with 4G modules or LoRa modules, you'll know it's quite difficult. And the way we've got this programmed and set up is unique to our specific application. However, we think there would be a lot of interest in having just that solar charging capabilities, the possibility of charging a large lithium iron phosphate battery from a very large solar panel that would interface with the Raspberry Pi, so it would be a hat that sits on top, and that would also provide power and battery monitoring as well. So we're currently thinking of launching that potentially as a Kickstarter. We're developing the prototype for that at the moment, so we'll do some testing. So let us know if you'd be interested in that and interested about hearing more about this project.